Hello everyone, good to see you again. So we are talking about the paper 2020 this time, and this is going to be the first half of this 2020 JMC paper. So let's take a look at what interesting questions we have this time, okay? So for the first question, it is definitely a number theory question. And I would say that it's on divisibility, or you can also say that it's on the prime and composite knowledge point, but then essentially we are still applying the divisibility to know whether it is a prime or not, right? So it says that exactly one of these 5 numbers is not prime, and which one is it? It's going to be 111, because we know that for the divisibility rules of 3, whenever I'm trying to add up all the digits, it's going to add up to a multiple of 3, right? So when I'm adding up all the digits, it gets me 3, which means that 111 is divisible by 3, and it is 3 times 37. Okay, so that's the first question. And the second one, super easy question. This is just numbers and operations. So it would be just simply division. Well, if you know how to observe the pattern of this calculation, 20 and 20 divided by 20, that's just going to be 101. But if you don't, well, you can use short division, long division, it's your call. So just 1 there, so you've got 20, and it cancels out, so you've got 0, 2. And of course, that's going to be a 0. So you've got 2 zeros there, drop the 2, drop the 0, and you've got 20 again. So that's 1 times 20 equals 20. So that's the answer, 101. That's the second question. Moving on to the third one. So for this question, well, the options are 1, 2, 3, 4, and 5. How many of these shapes have rotational symmetry of order 2? So basically, it would be a geometry question on rotational symmetry. So what is the order of rotational symmetry? Basically, it is just the number of times that the shape is overlapping itself while it's rotating for a full turn. So basically, for example, the most common example would be a rectangle, for example. So in order to know this answer, if any shape has a rotational symmetry of order 2, it means that it should look the same after doing a half turn and after doing a full turn, right? So all you need to do is just to turn your head around like that for 180 degrees. So turn your head upside down, or turn the paper upside down, of course. And whatever shape that looks the same when it is upright, that's going to be having a rotational symmetry of order 2. And we can see that the first one, the fourth one, and the fifth one, these are the 3 that's going to look the same when you turn your head or the paper upside down, like 180 degrees. So that's just going to be question 3. Yeah, the answer is C for 3, okay? And as for question 4, how many centimeters are there in 66.6 meters? That's again a numbers and operations question. And it would be about the conversion of units, or unit conversions. So of course we need to know that 1 meter is equal to 100 centimeters. So 66.6 meters will be equal to 66.6 times 100, which is 6,660 centimeters. And the answer is B. That's it for this one. For question 5, I would say that it's a little bit of a combination between defining new operation and also algebra. So you need a little bit of algebra skills to finish this question. So it will be about numbers and operations again. And it will be on defining new operations. So there are two ways you can solve it. The first way is by algebra. The second way is because it is a multiple choice question, so you can just put all these numbers into this function machine or into this operation to see whether it's working or not, right? So it says that Amrita thinks of a number. Let's say that number is x. She doubles it, so 2x, adds 9, add 9, divide that by 3, so that whole thing divided by 3, and subtract 1. And she obtains the same number she originally thought of. So she gets x. That's how we can write this whole equation. And then the next step, of course, we remove the single 1 first. So add 1 on both sides, you get 2x adding 9 divided by 3 equals x adding 1. And then, of course, you remove the fraction there, right? We don't want the denominator. So we times 3, we multiply 3 on both sides. On the left hand side, the denominator is going to get cancelled out. So it's 2x adding 9. On the right hand side, every single term is multiplied by 3. So I have 3x adding 3. And then finally, we just gather the like terms. So take away 2x on both sides and take away 3 on both sides, and you will get x equals 6. All right, so 6 is going to be the answer. That's it for question 5. And then question number 6. Super easy one. So numbers and operations again. And this will be about fractions. I believe you should be all getting this right. So essentially you can see that they're already with the same denominator, which saves me a lot of time. So I can just write a big denominator containing all the numerators. And the numerators are 6, take away 5, adding 4. So you need to track the signs. Make sure that you're getting the operations right there. Take away 3, adding 2, subtracting 1. And then you can see that every 2 of them can be grouped into 1, right? 6 take away 5, that is 1. And 4 take away 3, that is 1. 2 take away 1, that is 1. But of course, if you are not observing that, just do it step by step and you will still find the same answer, okay? And the reason why we can do that is because, well, addition and subtraction, they are of the same level. And that's the reason why. We usually do it in the normal order. But then in this specific case, we can see that actually each previous number is 1 bigger than the number that I'm subtracting. So that's the reason why I chose to take the lazy way and to group it. But then if you are not really familiar with BitMess, don't use this, okay? So we're going to get 3 of the 1s, which is 3 over 12. And that's going to be a quarter after simplification. So the answer is C. That's the 6th question. And then the 7th one, I would say that it is, again, a number theory this time. Number theory question. And it would be on the prime factorization. So whenever you see questions that are related to numbers having a product of some given number, you can just try to relate that to prime factorization, because prime factorization is going to help us break a number down into its basic, like smallest prime components of it, right, as the factors. So 110, if you prime factorize it, well, using the factor tree if you want to, or any other methods, as long as you can completely factorize it into 110 equals 2 times 5 times 11. But then we can definitely spot that there's only 3 numbers in the list, right? But we also know that those are already the prime components we can break it down into. So what is the other different positive integer? Of course, that's going to be 1. That's going to be 1. So don't forget about the factor 1 whenever you need to multiply it by something else without changing the value. Of course, you're multiplying it by 1, right? So we know that 1 times 2 times 5 times 11 is 110. Which means that I'm finding the sum of these 4 numbers. 1 adding 2, adding 5, adding 11. That is going to be 19. So the answer is going to be A. Okay? So that's for question 7. That's for question 7. And next for question 8. This is a counting problem. This is a counting problem. And I would say that it's on ordered enumeration. So basically, it says that he wants to color 2 of the cells black, such that the 2 black cells share a vertex but not a side. So this is definitely a square grid, right? Like a grid made of squares, which means that if you want 2 cells to connect by a vertex, you can only do top left and bottom right, or top right and bottom left. Yeah? Those are just the 2 different choices we have. So first of all, let's investigate the number of cases for top left and bottom right. Which means that I can just try to draw a line that is going through 2 boxes from the top left to the bottom right. So I've got 3 ways. And then what about top right and bottom left? I can just try to draw a line, again, from the top right to the bottom left. So I have that one and that one. So it means that I've got 2 ways. Altogether, there will be 5 ways in total. So the answer is 5. Does it make sense? Just like that. So for these kinds of ordered enumeration questions, well, you just need to know how to classify it into different categories before you start working on it. But I'm sure that this is pretty much a simple question, and most of you should be able to figure out the answer for this. And then for question 9, it is a word problem on fractions. This is a very typical type of problems. It is a word problem on fractions. So if you know that a fraction of a number is something, if you want to revert that fraction, like that number representing the fraction, back to the original whole, what you need to do is to divide it. So the original number is 2 divided by a fifth, so tracking it back 1 time, and then divided by a quarter 2 times, divided by a third 3 times, divided by a half 4 times. And that's all we need to do. Just trace it back all the way until you get to the original number. So that's just going to be 2 times 5 times 4 times 3 times 2, because dividing a fraction is multiplying the reciprocal of it, which means you flip the fraction and then you times it. And that's what we get. So it's going to be 240. 240 as the answer. So the answer is A for this one. Okay? And then question number 10, definitely an algebra question on linear equations. So how many of these have the solution x equals 12? We just need to solve it one by one. For the first one, x take away 2 is 10. So what is x? We add 2 on both sides, x is 12, which is correct. For the second one, x divided by 2 equals 24. So what is the inverse operation of dividing 2? Times 2. That's how we remove the denominator. So we times 2 on both sides, x equals 48. That is wrong. 10 take away x equals 2. So what do? Well, we can take away 10 on both sides, such that minus x equals minus 8. And x equals 8. So this is wrong again. And the last one, 2x take away 1 equals 25. So you add 1 on both sides first to cancel out the number, get around the like terms. 2x equals 26. Divided by 2, x equals 13. So that's wrong again. So we have 3 falses and 1 true. So the answer is going to be just one of them having the solution of x equals 12, which is the first one. Alright, that's how we solve this problem. Well, if you're strong in algebra, that's super easy for a question. And then question 11, I would say that actually it looks like a geometry question, but it is actually well, you can say that it's a geometry question, but then I prefer to call it a word problem. Why is it a word problem? Well, it's not like this question is set up in word problems, but then it definitely belongs to the interval problems. Because that's the key to solving this question. Otherwise, you're not drawing the 20 by 20 grid, are you? So why do I say that is an interval problem? It's because how do I get the 24 centimeters of wire in a 3 by 3 grid? That's because I have 4 horizontal wires, each of length 3 centimeters. And the 4 comes from 1 more than 3, because we know that if I have a 3 by 3 grid, I will have 3 intervals of 1. That's how the number of wires is 1 more than the gaps. For example, if I have 3 fingers, I have only 2 gaps between them, right? 4 fingers, 3 gaps. So the gaps are just the 3 centimeters. That's the reason why I have 3. I have 3 gaps, and then I have 4 wires, each of 3 centimeters, going horizontally. And the same works in the case when it is going vertically. So I have 1, 2, 3, 4 wires, each of 3 centimeters, because I have 3 gaps of 1. You see that? So we can imagine that in a 20 by 20 grid, there will be 20 gaps along the vertical direction, right? So it means that there will be 21 horizontal wires, each of 20 centimeters. So that's for horizontal. And what about vertical ones? I'm going to have 20 small gaps along the horizontal direction, right? Which means that I have 21, which is 1 more than 20 wires going horizontally, each of them having a length of 20 centimeters. So for the vertical direction again, 21 times 20. Altogether, that's just going to be 21 times 20 times 2, which is 840 centimeters. That's going to be E. All right, so E is the answer for this question. And then for question 12. So again, a very simple question if you know what to do. So this is a geometry problem, and it is about cutting regular shapes. So how do we cut it? Basically, I just need to cut each small equilateral triangle into 4 parts, such that altogether I have 16 parts, and then 3 parts are shaded out of 16. So I have 3 over 16. That's it. Or, of course, you can use the numerical way to do it. I can see that I'm just looking at one out of the 4 equilateral triangles. So I've got 1/4, so representing this triangle. And inside this triangle, only 3 parts out of 4 are shaded. So 1/4 times 3/4, that's 3/16. Again, same answer, okay? So whichever way you like, numerical way, graphical way, both are okay, okay? Easy. As for question number 13, this one is really testing your concepts. So I would say that it belongs to the statistics, which the statistics belongs to counting, essentially. So it's about the mean and the median. Median. We know that there are 4 numbers in the list, and the mean is 5. So in other words, the total of the 4 numbers is equal to 5 times 4, which is 20. Because the total divided by the number of numbers is the mean. So in other words, you can rearrange that to know that total is the mean times the number of numbers. And the median is 6. So what does it mean by the median of 4 numbers? We know that median means center number, right? But if I have got 4 numbers, 1, 2, 3, 4, I don't have a middle number. So the median is going to be in between the 2 numbers, which means that the median is the average of the middle 2 numbers. Does it make sense? So if I name these 4 numbers A, B, C, and D, going in an ascending order, it means that the median there is 6, which means B adding C is 6 times 2, that is 12. Does it make sense? Because I'm dividing B adding C by 2 to get 6. So revert that calculation, you times 6 by 2, you know the sum of B and C. And we know that the total is 20. Oh, that's a poorly written 20. So it means A and D, which are the largest and the smallest numbers on both ends, is going to add up to 20, take away 12, which is 8. So the mean, we're not looking for the sum, we're looking for the mean. The mean is equal to mean of A and D is 8 divided by 2, accounting for the 2 numbers, equals 4. Okay, so in the whole story I didn't know any single number, but then I still worked it out. Of course, you can also try to substitute some numbers in there. That would also work. Okay. Then we have question number 14. So it is a geometry question on angles. It says that angle OLM is twice as large as angle PON, but we are not given any of these 2 angles. So what I can do is that I can just set them as unknowns. Let's say angle PON is the smaller one, so I will name it X. Angle OLM is therefore 2x. And now I can definitely do something there. For example, I can try to find that angle LKO. And this angle LKO adding 124 degrees is 180 because they're going to be the angles on a straight line, right? So it will be 180 degrees, take away 124 degrees. That's equal to 56 degrees. Yeah. So that's 56 degrees. That's what we know. And then the second step is to look at this angle, which we also know, LOK. So the angle LOK is equal to x, because That's the vertically opposite angle of PON. Yeah? So now I can list an equation by the exterior angle equals the two interior angles adding together. That's a geometry rule that I've been talking about many times, but still lots of you are forgetting about it. So this is very important because it is widely applicable in the questions at this stage, especially when it is related to triangles. Okay, so I know that OLM, which is 2x, is equal to 56 degrees adding x, which are the angles LKO and LOK, the two non-adjacent interior angles. So cancel out one x on both sides, I can see x is 56 degrees. And what are we looking for? We are looking for the size of angle OLM, which is 2x. That's equal to 2 times 56 degrees, which is 112 degrees. So D is going to be the answer to this question, okay? And the last one, question 15. This is an inclusion and exclusion problem. So it belongs to the counting module. And it would be about inclusion and exclusion. So it says that a group of 42 children all play tennis or football or both. So I can just try to draw two circles there as a two-set Venn diagram. So let's say one of them is red, the other is green, okay? All right, so this is for tennis, this is for football. Now, the first sentence tells us that a group of 42 children, so it means that altogether there will be 42 people in the whole set, like in the whole universe. And the same number play tennis as play just football. So it means that the red circle and this green moon shape are going to have the same number. But then if I am just putting the unknowns here, that would be a little bit too fast. Well, or not, because I know the total number, right? So definitely I can find out the number of people who is playing tennis or just football. But then, it's your choice. It's your choice. I would like to read through the whole question first, usually. So the second statement is easier to use than the first one because it says that twice as many play both tennis and football as play just tennis. So that's more specific because that's pointing at directly at each zone of them, right? So just tennis is just that red moon shape right there. So that's going to be an X. And twice as many play both tennis and football. So that rugby shape in the middle has got 2x. And finally, back to the first question, the same number play tennis as play just football. So tennis has got 3x altogether, right? X adding 2x. So just football, which is this right-hand side moon shape, is 3x. So now we know that altogether there are 6x students, which means that 42 equals x adding 2x adding 3x, 42 equals 6x, and x equals 7. How many of the children play football? 2x adding 3x, right? So it's 2x adding 3x, which is 5x, that is 5 times 7, that is 35. So 35 is the answer for question number 15. All right, so in general, this half of the paper is pretty easy, and I can see that most of you are doing pretty well in it. So well done, and I will see you all on Thursday again, okay? Bye-bye.